Now we go to fundamental problem F88. You have two blocks, block A and B, and it is supported by this kind of configuration, right? So you have two pulleys, one rope going through them, okay, like this, and there is this floor is inclined at an angle of theta, right? So the question and between all contacting surfaces, between A and B, you see, between, and also between B and the floor, the inclined floor, the inclined surface is mu as the coefficient of static friction. Okay, so the question asks you, of course, they have the weight of W, both identical, right? And then the question asks you to determine the inclination angle at which the identical block start to slide. Okay. Okay. In reality, what you can do, I mean, this just a side note. What they do is basically they incline it up to the point that actually it starts to slide. That's what we discussed, right, in the lecture about the experiment to determine this mu as this coefficient of static friction experimentally. But now we want to find what's the relation between this mu s with the theta, right? I mean, what is theta that this happens? Okay. Okay, now try to understand this. If let's say you try to incline the angle to the point that this block starts to move, right? So what happened in this case? Can you see that because of this kind of pulley system, block A will start to slide down too, right? Slide down means that going to the left, roughly, isn't it? Okay, so and then A going down, B going up, isn't it? Okay, so what you have to do is, after you understand, you realize this kind of configuration, what you have to do is you do the free body diagram. Let's start with block A, see what happens. Okay, free body diagram of block A. You have this inclined block A, right? Then you have the weight W. Okay, and then you have, okay, about this weight W, how do you understand this angle? Because W is vertical, right, going down, but now we have that angle. So basically what you have is between W and the horizontal line is theta. This theta. Okay, how I got this, I have explained in the previous chapters. Okay. Okay, what else? So you have T, right? The tension from the cable or the rope. Okay, and then of course this T will have an angle with a horizontal line of theta because you incline this as theta, right? Okay, what else? You have NAB, which is normal to the surface of block A. Okay, this is the normal force exerted by block B to block A. Okay. What else? You have this FAB. What is this? This is the friction force between what? Between block A and block B. Why it goes to the kind of to the right? Because it will oppose the motion of this sliding down, right? Sliding down due to the weight, so it will oppose this by ST to the right. I'm talking this right means that the horizontal component, okay? Of course, it's not to the right. It has an angle, and that angle is basically theta, right? Okay. To ease you, what we can do is we define XY to be inclined at 30 degrees from the horizontal line, right? Do it as XY. So that when you do this fx0, f0, it will be easy, right? So you can start solving it. Fy equals to 0. Fy not going up horizontally, it is slanted, right? Fy equals to 0. What do you have? You have minus W cosine cosine theta. minus W going down cosine theta. Okay, the y component of it. Okay. What else do you have? You have plus NAB and what else do you have? That's all, isn't it? Because this T and this FAB is actually solely a X component, right? So here you can express this NAB in terms of W, which is W cosine theta. Right? Again, you can do W equals to blah blah NAB something, but it's not the thing that we want to do. We don't want to find what is NAB in this case. Eventually, we want to find W integration of theta, something like that. I mean, W theta will be in the next equation. So we express NAB in terms of this, not the other way around. Okay. Next, we do fx equals 0. Of course, like I said, fx has a 30-degree angle between it with the horizontal line, right? And then here you have t. Of course, here you don't need theta, right? T plus FAB, isn't it? Minus W sine theta equals to 0. Okay. T plus FAB minus W sine theta. This component. This is X, right? Okay. And we are evaluating this at the verge of slipping, right? So you know that your FAB, in this case, it is mu S and AB, isn't it? Right? So you put this FAB into the equation, you will have your T equals to W sine theta minus FAB, which is mu S and AB. Okay? And your NAB, okay, to simplify further, because we're going to use this W sine theta minus mu S. NAB is what? It is W cosine theta. Okay, so this is the equation, because later on when we do on block B, we will put this P into that, and then we will solve for W and theta and all this stuff. Okay, so now we go to free body diagram of B. Okay, what do you have? You have this block. You have the weight of 50 times W weight. Okay, and then of course you have this angle theta between this weight with the vertical line of it. Okay, here again you define X and Y like this. Okay, of inclined phase, and then you have N and B, right? The normal force. What else? Is that okay? When it moves, it will move up, isn't it? So what happens is that this mass resist FB, isn't it? Because it tends to move up. So this FAB will go down to resist that one. And you have another one. You see, between this and this, you have the FAB. In this case, it goes up. So here it goes down, FAB, right? You see, you have two in this case. In block B, for block B, you have two friction forces. One is FAB from before, and FB between this block B with the floor, the inclined floor, right? So you have to be careful here. And then what else? You have here, you have the pulley, right? Initially you have this kind of pulley. I'm going to make up for that later. You see, you have this T. Because this rope T with tension T, it goes all the way, right? So you have T here, you have T here, right? Like this. So the equivalent of it will be, I mean, you can draw the figure for the pulley as well, but it will be 2T. Okay. What else you have? You have something more, which is NAB, right? The normal force between them. So you have NAB as well here. NAB. Wow, so many forces. But no worries, we will get there. Okay. So again, this is the problem on the verge of sleeping. So you say that your FB here equals to mu S and B. Okay. Because you have written this one in this box to move, right? To move. So first you do. I think let's just erase this one because you already got the T. The most positive is the T over there. Let's leave the T. Okay. Then we go up. Right. Okay. We do. What do you want to do? Okay. We want to do Fy equals to 0. Summation of Fy equals to 0. Going up as positive, I mean going this up. So you have minus NAB, right? What else? You have minus W cosine theta. What else? You have NB plus NB. Do you have another equation in y direction? No. So equals to 0. Okay, the equilibrium. And then from here, you express your NB as NAB plus W cosine theta. Okay, and you know from before that your NAB. Okay, I made mistake. Actually, I accidentally did it, but your NAB from before was W cosine theta. So this one equals to this one. NAB is W cosine theta as well. From row A, okay? From previous one, you can check that. So your NB is actually 2W cosine theta. Okay? Actually, you just realize that you can put this NB later on here. Maybe you express FT. Okay, but we'll be going to do that later. And then you have done Fy equals to 0. Next you do Fx equals to 0. Okay? Fx equals to 0. What you have? You have 2t, right? Cosine 2t. What else? You have FAB minus FAB. You have minus FB. And you have what this? What's this? Minus W sine theta. Isn't it? 2t plus minus FB minus FAB minus W sine theta, this component, isn't it? Equals to 0. Okay, you realize that you have t from before, right? So we're going to do. So we will put this t into this. So you'll have W mu S and theta, right? And then you have your FAB from before as well, US NAB, and then you have this your FB as well, US NB. Okay. So when you solve this, okay, when you solve this, you will have 2W sine theta minus 2 mu S W cosine theta, right, minus W sine theta minus mu S W cosine theta, okay, minus mu S 2W cosine theta, right? Oh, sorry, no, it's fine. Okay. Let me do it again. Sorry. Okay. If you lost track with this, look at all those things before. I mean FAB and what is the T in terms of those W and theta. Okay. So from here, what you do is you have 2t, right? Which is 2t minus FAB, which is W sine theta, minus mu S W cosine theta, okay, and minus mu S 2W cosine theta, okay, equals to 0. And then you solve this, I mean you put the t from before, right, and then it will become 2W sine theta minus 2 mu S W cosine theta, okay, minus W sine theta minus mu S W cosine theta, okay, minus 2 mu S W cosine theta equals to 0, right? And then at this point you can see that you have W theta and mu S, right? Right? You can, in this case, you can factorize W and then you can cancel them out. Okay. What you have is that W will be cancelled out for each terms. Okay, and then just left with the mu S and theta, and you have basically here you have tangent theta equals to 5 mu S. So your theta is a tangent of 5 mu S. Okay, so this is the relation between theta, the angle, with your mu S. Or actually even mu S with theta, it doesn't matter. Okay.